This is Wild Maths.
Alright, here we go. Last question. Very psyched about this one. So circle equation, coordinate geometry again. So first of all, we've got to find the equation of this circle, and then we've got to try and prove that that point is on the circle. So I'm doing a little sketch. So 2, 6 is our centre, and 10, 11 is a point somewhere on the edge of the circle. So the first thing we need to do is to remember what the equation of a circle is. So remember, it's x minus a squared plus y minus b squared, and those are the coordinates of the centre of the circle, equals the radius squared. So we've got the centre, we just need the radius, and all the radius is the length between the centre and the circumference of the circle. So we've got a point on each, so we can just put those into the equation of that line and work out that the radius is going to be 13. So we just need to put all that together. So we got x minus x plus 2 plus y minus 6 squared equals 13 squared. Make sure you check all that through. You don't want to put the wrong point in the centre. And last bit, we just need to test, does 10, 1 lie on that circle? So we're going to substitute in x equals 10 and y equals 1 and check that 13 does equal 13. So yeah, there we go, 13 does equal 13. So we've proved that point is on the circle. Next bit, find the equation of the tangent at the point and the point P. So point P is where the tangent meets the y-axis. So I've drawn my circle again with a tangent there. So we've got the same centre and the same point on the circumference. So what we need to do this time is find the gradient of the radius, or the normal, and then we're going to do the negative reciprocal of that gradient to find the gradient of the tangent, and then we're going to use that gradient and the point on the circumference in our equation of a straight line to get our line equation, and then we can check where that crosses the axis. So again, label your coordinates so you don't make any mistakes. Most common thing was people mixing up x's and y's and point 1, point 2. So y2 take y1 over x2 take x1 again, giving us a gradient of 5/12. That's the gradient of the radius, or the normal. So we need to do the negative reciprocal of that to find the perpendicular gradient, which is going to be minus 12 over 5. And then we're going to use that gradient in the equation of a straight line with the point that's on the circumference. Make sure you use the right point, otherwise you're just going to find a random line that goes through the circle rather than the line we're after. So once you've got it all in the equation, you've now got most of the method marks, so well done. All you need to do now is expand that and find out where it crosses the axis. So there we go, there's our equation of the line. So y equals minus 12 fifths x plus, I think it's going to be 35. There you go. So where does that cross the y-axis? Put in x equals 0 and you're left with y equals 35.